Okay, I hope I'm audible to all students who are attending this lecture of Introductory Econometrics. We intend to continue with our discussion of the back problems for chapter 2, which is from the book Essentials of Econometrics by Gujarati and Porter. So in this particular lecture, we continue with some of the back problems. In the previous lecture, all students can recall that we had solved problem 2.4 from chapter 2 of Gujarati and Porter. Okay. The edition I refer to for solving these problems is the 4th edition. Okay. And in this particular lecture, we intend to look at some more problems from chapter 2, which is linear regression. Okay. So let's look at problem 2.7. Let's look at problem 2.7. Okay. So the following table gives pairs of dependent and independent variables. The following table gives pairs of dependent and independent variables. In each case, state whether you would expect the relationship between two variables to be positive, negative, or uncertain. Okay, so let's quickly look at the table which is given to us. I am drawing exactly the same table which is there in problem 2.7. Okay, I can even write the page so that it's easy for students to locate. So as per the 4th edition, it's page 45 of the book. As per the 4th edition. Okay, so let's look at the table. So we are given the dependent variable here. We are given the independent variable here. And the relationship between the two, I am going to write here. So what relationship we would expect? Should it be positive, negative, or uncertain? Is something which I will be writing here. So dependent variable we always denote by y, independent variable by x, relationship between y and x. Okay, so let's look at the first part, GDP. GDP is my dependent variable and rate of interest is my independent variable. Now, what relationship we would expect between the two? Now, guys, it depends upon the components of GDP. Now, all students can recall that the GDP of the economy, which we denote by Y, is equal to C plus I plus G plus NX. This is the standard macroeconomic identity which we have done. The GDP of the economy, which is also equal to the income demanded, is equal to consumption demand plus investment demand plus government expenditure, which is captured by G, plus the net exports, which is export minus import. Now recall that when we were doing our lectures in introductory and intermediate macroeconomics, where we had done the IS and LM curves, okay, then we had clearly said that income and interest rates share a let me correct myself, interest rates and investment, they share an inverse relationship. So recall from my ISLM lectures, which we had done in our macroeconomics course, intermediate and introductory macroeconomics courses. Recall from our ISLM lectures that investment and interest rate, suppose I denote the interest rate by small I, share inverse relationship. Because all of us know that when the interest rate goes up, firms are going to reduce the investment, because if firms go to the banks for funding in order to make investments, when banks increase the interest rates, the cost of borrowing from the bank goes up. As a result, firms are going to reduce their investment. So we can say that capital I and small I share an inverse relationship. And since capital I is also an important component in determining the GDP of the economy, I can say that therefore interest rates and GDP share inverse relationship. I and GDP share negative relationship. So I can say that an increase in the rate of interest will reduce the GDP of the economy via a fall in investment. When interest rate goes up, investment falls. So I can write that when interest rate goes up, investment, which is capital I, falls, which implies GDP also falls. So we would expect the relationship between GDP and interest rate to be probably negative. Okay. So now when I say this, I'm keeping all of the factors constant. Remember, it's always ceteris paribus. Ceteris paribus means I keep all of the factors influencing the GDP constant. Okay. So let's look at the second part, part B. Part B, we have the dependent variable as personal savings. And our independent variable is the rate of interest. Now, all of us know that when the rate of interest goes up, it encourages savings. So I can write an increase in the rate of interest encourages savings, because for every dollar you save with the bank, you will be getting more returns when the rate of interest goes up. So I can say, therefore, we would expect a positive relationship between the personal savings and rate of interest, between the rate of interest and personal savings. We would expect the relationship between these two to be positive. Okay, so I hope part B is clear. Erasing the initial part, I can do part C on the top. So if you look at part C, so in part C, our dependent variable is the yield of crop, and our independent variable is rainfall. Now here comes a bit of agricultural economics. Obviously, a good rainfall would mean a better harvest and good yield. So I can write a good rainfall would mean a better harvest and high yield. Therefore, we would expect positive relationship. We would expect a positive relationship between rainfall and yield of the crop. I always write the independent variable first and then I write the dependent variable. But guys, the order doesn't matter. You can even write positive relationship between yield of the crop and rainfall. That's completely up to you. I always have the practice of writing the independent variable first and then the dependent variable. Okay. So hoping students have understood this. Okay. Then we can look at part B. So if you look at part D, that is US defense expenditure. and Soviet Union's defense expenditure. Now, Soviet Union is Europe. If the defense expenditure of the Eurozone or the European economies go up, if the European economy starts spending more on defense, then US is also going to spend more on defense to deter or to signal that they are also a powerful economy. Okay, so remember, when one strong economy starts spending on defense, other economies also start imitating by spending on defense. Spending on defense gives a signal that the economy is well prepared in case of a war. Okay, and it's a strong economy, so we can say that we would expect a positive relationship between the Soviet Union's defense expenditure and US defense expenditure. Because if the Soviet Union's expenditure goes up, US would also want to spend more on defense. Okay. So let's look at part E, raising this part off. So part E, we have the dependent variable as number of home runs hit by a star baseball player and annual salary. Okay, so now guys, when we talk about the performance of a player in baseball, it not only depends upon the capabilities of the player, it also depends upon the equipments. Okay, what's the equipment, or I can say what quality of equipment that baseball player is using, and what the quality you use depends upon your interest. So I can say that baseball players whose salaries are very high tend to use very good quality baseball equipments, and very good quality baseball equipments might also be one of the reasons for scoring more home runs. Obviously, it also depends upon the potential of the baseball player. It's completely possible that a baseball player may not be earning very high but still scores very high home runs. But one possibility could also be the case where richer baseball players tend to use more good quality baseball equipments, which in turn helps them to score more home runs. So again, I would expect the relationship between the two to be probably positive. We would expect a positive relationship between annual salary and the number of home runs hit. Number of home runs hit by star baseball player. Okay. So let's look at part F, erasing this part off. Let us see. Let us see what is part F telling us. So in part F, we have a president's popularity. A president's popularity and length of stay in office. Now, there are many ways in which you can think about it. It's a political based question. So we can also say that the longer you stay in office, now if you're doing good, so this question is basically normative in terms of judging whether the relationship should be positive or negative. If you stay in office for a longer tenure and your good activities are being observed, your popularity will grow. But at the same time, the longer you stay in charge, more is the tendency to look at the mistakes you have made. And obviously, no politician is perfect. We can't say that, we can't talk about any politician who is actually perfect. When humans are not perfect, how can politicians be perfect? So there is a higher tendency towards evaluating the mistakes a politician has incurred over his stay. So again, if I go by the second judgment, I would expect the relationship between the two to be negative, because the longer you stay in charge, higher is the tendency to look at the black spots. Black spots means the mistakes you have done over your tenure, which might cause your popularity to go down. Okay, so but having said that, everyone can have its own opinion. Basically, it's an empirical question. You need to test it empirically. So, but I can write what I feel is that I would expect the relationship to be negative. I can write, we would expect the relation to be probably negative. You would expect the relationship to be probably negative. Okay, because the more longer you stay in office, that means the more longer you stay in charge, higher is the tendency towards looking at your mistakes, the mistakes you have incurred over the period of time, and that might cause your popularity to go down. Because even if we talk about the opposition party, the opposition party will not be going to talk about the good deeds you have done over your tenure as the president. The opposition will always say bad about you. That is all politics is all about. The opposition is never going to praise the president who is in power, or even the political party who is in power. The opposition will always say things which are not in favor of you. So the longer you are staying, the longer the opposition gets a chance to say things which are unfavorable to you, and that might cause your popularity to go down. So I can write this: the longer one stays in office, one stays in office means in charge as the president, okay, higher the chance, or I can, instead of writing it like this, I can write longer the comments of the opposition, longer the comments of the opposition party unfavorable to you, unfavorable to the required person, which might cause popularity to go down, which might cause the popularity to go down. So it's a very bleak chance that you would expect the relationship between this and this to be positive. Mostly it's going to be negative, because the more you stay in office, the more opposition is going to say bad about you. Suppose I was the president this year, and suppose in the next elections also I come up as the president, okay, for the US economy I'm saying, then what is going to happen? The opposition gets more chance to say rubbish about me or say unfavorable about me. So my popularity might tend to go down, because the opposition has got a long time to say things which are unfavorable to my party. So we would expect the relationship to be somewhat negative. Okay, let's look at part G. Erasing this part off. So in part G, we are given a student's first year grade point average, a student's first year grade point average, and his SAT score. Obviously, higher the SAT score, higher will be the if your SAT score is high, it means your abilities of solving problems are higher, which means that you are expected to score a higher grade in your first year. So we would expect the relationship to be probably positive. I'm just writing probably positive. I'm not wasting time in now writing the complete sentence. We would expect the relationship to be probably positive. If your SAT score is high, it means your abilities, your mental abilities, capabilities are higher. You are a bright student academically, which means you're expected to score a higher grade point in your first year if your SAT score is higher. Okay. Again, guys, important point is that this is all based on ceteris paribus. That means all of the factors are kept constant. When I look at the relationship between the SAT score and the first year score, I am keeping all other factors constant. Okay. Let's look at H, a student's grade in econometrics and grade in statistics. Now, all of us know that statistics is the prerequisite for studying econometrics. All of us know that. We can write statistics is the prerequisite. It is the prerequisite, or I can also say foundation for studying econometrics. So again, we would expect that if your grades in statistics are good, you are going to perform well in econometrics also. So again, I would expect the relationship to be probably positive. Again, it's all ceteris paribus. Okay. So if your grades and stats are good, we expect you to perform well in econometrics because statistics is a prerequisite for studying econometrics. Okay. And then part I, imports of Japanese cars. Import of Japanese cars and US per capita. Now we have done the relationship between income and imports in our intermediate macroeconomics part 2 course. In our lectures on open economy models, within our lectures on intermediate macroeconomics part 2 course, we have learned that how imports are positively related to your income. Okay. So I can say, I can write this sentence. Higher the US per capita income, more will be the imports of Japanese cars. Japanese cars are usually expensive and they are good quality cars also. We would expect the relationship to be probably positive. If the US per capita income goes up, that means if the US economy is becoming richer, it's going to spend money on importing more good quality Japanese cars. So we would expect the relationship between the US per capita income and the import of Japanese cars to be probably positive. So with this, our problem 2.7 is over. The objective was to basically look at the relationship between the set of dependent variables and independent variables given. Some of them you can argue logically. Some of them you can argue using the underlying economic theory. Like the part E is based on underlying economic theory. Part H is all logic. Again, part G is all logic. So you can form a relationship between dependent and independent variables, sometimes using the underlying economic theory behind it, and sometimes using common logic. Okay. So problem 2.7 is done. Let's look at problem 2.8. Again, this is another back question from the book. Okay. State whether the following models are linear regression models. we need to find out whether they are linear regression models. So again, I'm drawing a table where I'm writing the parts on one side and the answers on the other side. So we are given some regression models. Let me write all of them first of all, and then we can answer all of them collectively. So these are all the models given to us. So we need to recall what is actually meant by a linear regression model. We have clearly done this in our lectures on linear regression. Okay, so let me just write the last part and then we can take it up for discussion. So these are all the regression models given to us, the population regression functions, and we need to argue which of them is linear and which of them is non-linear. So first of all, please recall that any regression model is said to be linear if it's linear in the parameters. It may or may not be linear in the variables. Okay, so first of all, I can just write a note. Okay, I can write a note that a regression model is said to be LIP. LIP means linear in parameter. Let me write a regression model is said to be linear if and only if it is linear in parameters. It may or may not be linear in variables. It may or may not be linear in the variables. Okay, so I'm revising it again. A regression model is said to be a linear regression model if and only if it's linear in the parameters. Linear in parameters means B1 and B2. B1 and B2 are the parameters. It may or may not be linear in the variables, which are yi's and xi's. So now the question becomes very easy. So let us see whether the following models are linear regression models. Look at the first one. Is it linear? You ask yourself, is it linear in B1 and B2? If your answer is yes, it's a linear regression model. If it's not linear in B1 and B2, it's not a linear regression model. So this is a linear regression model. Since it is linear in capital B1 and capital B2. This is also a linear regression model for the same reason. It's linear in B1 and B2. This is also a linear regression model. Okay, since it is linear in B1 and B2, that the reasons are all the same. This is also a linear regression model. Since it is linear in B1 and B2. Is part E a linear regression model? No. So I can write not a linear regression model because B2 and B3, they are not linear. They are multiplied with each other. Since it is not linear in B2 and B3, because we have their product, which is not linear in either of the two. And the last one is also not a linear regression model because you can clearly see it's B2 cube. So I can write since it is not linear in B2. Since it's not linear in B2, it's not a linear regression model. So these are our answers. Out of the models given to us, only E and F are not linear regression models because you can clearly see they are not linear in the parameters. Other models A, B, C, and D are all linear regression models because they are linear in capital B1 and capital. Okay, so hoping students have understood this. And then I intend to do the last problem for this lecture, after which we stop. Problem 2.9. Let's discuss problem 2.9 now. Okay, so in problem 2.9, what are we given? We are given some data. Okay, so if I write this, we are given some data. Given the following data, on weekly family consumption, expenditure, which is Y, which is given to us in dollars, and weekly family income, which is X in dollars. So we are given the data between the family consumption expenditure and the weekly family income. The data is given to us as follows. So we are given weekly income. Weekly income in dollars, this is our variable X. And we are given weekly consumption expenditure. In dollars, which is our variable Y. Again, we are given for every value of X, you have different values of Y given to you. For each value of X, you have different values of Y. It's actually a mechanical question, but still we can take it up for discussion. So I am first of all writing the values given to us. It's a tedious process to write these values. Although I think when we solve this question, it's an easy question. So students, while attempting this question, please sit with your calculators. It might involve some calculation. So these are all the values. You can see that for fixed values of X, you have Y taking different values. Okay, we are left with two more. I hope the space allows us to write the remaining values. And the last value of X is 260, corresponding to which I'm just writing the values. I hope they are clearly visible. I'm also reading them out: 150, 152, 175, 178, 180. I'm writing this one clearly again: 180, 180, 185, 191. So the last values, guys, so that students are perfectly clear, I'm repeating again. For 260, my values are 150, 152, 175, 178, 180, 185, 191. So this is the data, or I can say the table which is given to us. And now let us see what is the question asking us. So the question is asking us that for each income level, compute the mean consumption expenditure. That is the conditional expected value. So guys, I need to find out expected value of Y given Xi. Now that is very simple. For a given fixed value of X, I need to find out the mean. What is the mean? So I can do for one, others you can do on your own. This is going to be 55 plus 60 plus 65 plus 70 plus 75. You add up all the values divided by how many values are there? 1, 2, 3, 4, 5. So you divide by 5. You get your answer as, you can verify it comes out as 65 only. That means for a fixed value of x, we have calculated the mean value of y, or I can say the mean or the expected value of y. Conditional on xi. So this is my x1. This is x2, x3, x4, x5, x6, x7, x8, x9, and the last one is x10. So this is nothing but expected value of y conditional on x1. Similarly, guys, you add all of them up, you divide by the total number of observations, you can verify, you get the answer as 77. This is expected value of y conditional on x2. Similarly, you add all these values and you divide by the total number, you get 89. This is expected value of y conditional on x3. And similarly, I can write all the remaining answers. 101, expected value of y conditional on x4, 113, expected value of y conditional on x5, 125, which is the expected value of y conditional on x6, 137, which is the expected value of y conditional on x7, 149, which is the expected value of y conditional on x8, 161, which is the expected value of y conditional on x9, and the last one is 173, which is the expected value of y conditional on x10. So for every value of x, we add up the y values, we divide by the total number, we get the expected value of y conditional on a given value of x. Okay, so now what is the next part asking us? The next part is asking us plot a scatter diagram. So we are not going to plot it. Plotting is something which you can do on your own. Draw a scatter plot between expected value of y conditional on xi on the y-axis and weekly expenditure xi on the x-axis. So guys, all of you know how to draw a scatter plot. Basically, you plot the points. You plot 65 on the y-axis with 80 on the x-axis, 77 on the y-axis with 100 on the x-axis, 89 on the y-axis with 120 on the x-axis, and so on. And you join all the points. So first of all, look at the relation. What do you expect? You can see that when the weekly income is going up, when it's increasing, you can see that your mean or expected value of expenditure is also going up. 65, 77, 89, 101, and so on. So you would expect the scatter plot to be upward sloping. The scatter plot will be upward sloping. Will it be concave, convex, or linear? For that, look at the slope. How do I find the slope? Very simple. It's nothing but change in y by change in x. So you can clearly see that for every increase in weekly income, you can see that weekly income every time is increasing by how much? It's increasing every time by 20. From 80 to 100, 100 to 120, and so on. So you can see that your mean or expected value of y on x is increasing by how much? 77 minus 65 is how much? 12. So it went up by 12. 89 minus 77, 12. 101 minus 89, 12. 113 minus 101, 12. So every time you observe what? Every time when your weekly income goes up by 20, your mean or expected value of weekly expenditure goes up by 12. So if you look at the slope is what? Slope is nothing but 12 by 20, which is nothing but How much? 3 by 4, which is constant. You can see that your slope is constant. So it's upward sloping, and since my slope is constant, I can write linear. So when you guys will be drawing a scatter plot, you will observe that it's upward sloping, which shows that an increase in weekly income increases your expected weekly consumption expenditure. But since the slope is a constant, because for every $20 increase in weekly income, your expected weekly expenditure goes up by $12. Your slope is a constant, which is 12 by 20, which is 3 by 4. As a result, we can say that it is linear, because whenever the slope is constant, your function is linear. So it's upward sloping and linear if you draw the scatter plot. Okay, then the question is asking us that what can you say about the relationship between y and x and between mean y and x? So you can clearly see that we can say that the mean of y increases with x. When x goes up, which means when your weekly income goes up, your expected value of y, which is conditional on the weekly income, which means your expected weekly consumption expenditure also goes up. So you can answer these questions orally. And then part E is asking us write down the population regression function and sample regression function for this example. So I can quickly write the population regression function. So how will the PRF look like? So if I erase this particular part, how will the population regression function look like? So my population regression function will be of this particular form. Yi is equal to capital B1 plus capital B2 xi plus ui. This is my stochastic population regression function, where yi denotes what? Where yi denotes my weekly consumption expenditure. Yi denotes the weekly consumption expenditure. B1 plus B2 xi is equal to expected value of y given xi, which is nothing but my deterministic component. And xi itself is what? We know xi is nothing but my weekly income. This is my population regression function. Corresponding to it, my sample regression function will be yi equals capital B1 will be estimated by small b1 from the sample. Capital B2 will be estimated by small b2 from the sample. And EI will be my sample residual term, which we use to estimate the population disturbance term UI. So this will be my corresponding sample regression function, where yi and xi are as defined. Okay, so and if you draw the scatter plot, which is part F for problem 2.9, if you look at part F, is the population regression function linear or non-linear? You can clearly see that it's linear because your slope is a constant, which is equal to 3 by 4. For every $20 increase in your income, your weekly consumption expenditure, your expected or mean weekly consumption expenditure increases by $12 every time. So I can say that my slope is a constant, which means my PRF is a linear. My scatter plot is a linear. Okay, so this is where I intend to stop in this particular lecture. We have discussed a few questions from the back problems for chapter 2 of linear regression from the book Essentials of Econometrics by Gujarati and Porter. We'll discuss more back problems from chapter 2 of the same book in the next lecture of Introductory Econometrics. So I hope all students have enjoyed this lecture. Any doubt, you can unmute your mic and ask, or call up or mail me your doubts at divineschoolof economics@gmail.com. So this is where I stop in this lecture.